Okay, hello Cloud Gurus and welcome to this lecture. This lecture is on NAT instances and NAT gateways. So NAT just stands for Network Address Translation. And essentially what we want to do is enable our EC2 instances in our private subnets to still be able to go out and to download software. And in order to do that, they need a way of communicating to our internet gateway. However, what we don't want to do is make our subnets public. We still want a degree of control. So what we're going to do is create these things called NAT instances and NAT gateways. Now, 9 times out of 10 or in the real world, you'll always be using NAT gateways. NAT instances are individual EC2 instances that do this, whereas NAT gateways are highly available. They're not just one EC2 instance, they're spread across multiple availability zones. They're not dependent on a single instance. NAT instances are completely on their way out, but they are still in the exam. I still had a question on NAT instances literally like 2 weeks ago. So you do need to know the difference between a NAT instance and a NAT gateway. A NAT instance is literally just a single EC2 instance. A NAT gateway is a highly available gateway that allows you to get allows you to have your private subnets communicate out to the internet without becoming public. So what we're going to do is we're going to start with NAT instances. I'll show you how to create one, and then we're going to move on to NAT gateway. So I'm back in the AWS console. We're going to go over to services. I'm going to go to EC2. We're going to go ahead and launch an instance. We're going to launch this instance into our public subnet. We're going to go over to community AMIs, and in here we're going to type in NAT and hit enter. And this will give us our NAT instances. So go ahead and select the very first one. I'm going to leave everything else as default. I'm going to change obviously the VPC over to our custom VPC, and I'm going to make sure I launch this into my public subnet, and that will also give me a public IP address for this instance. Next, I'm going to add my storage. I'm going to add my tags. I'm going to go in and give this a name. I'm going to call it NAT underscore and then instance, and then I'm going to go ahead and add it to my security group. I'm going to do an existing security group. We're going to put this into our web DMZ security group. I'm going to go ahead and hit review and launch. It's asking me if I want to boot from general purpose SSD. I'm just going to click the second one. I've never actually seen this before. Maybe it's just the AMI that I'm using, but I'm going to go ahead and just hit launch. And then I'm going to use my new key pair, which I got in the last one, and I'm going to go ahead and launch that instance. So that instance is now being launched, and you can see that it is launching into US East 2A, and it has a public IP address. While I wait for this to come up, I just want to show you something. So I've put a link to the resources section to this page in the resources section of the course. This will explain all about NAT instances. But essentially, we've just gone through the process of setting up a NAT instance. We've been using the Amazon Linux community AMI. If you scroll all the way down, it's going to tell you about disabling source and destination checks. And each EC2 instance performs a source and destination check by default. And this means that the instance must be the source or the destination of any traffic that it sends or receives. However, a NAT instance must be able to send and receive traffic when the source or destination is not itself. Therefore, you must disable source destination checks on the NAT instance. So basically, our NAT instance is acting as a gateway. It's acting as a gateway. I hate using that term, but it's acting as a gateway to our internet gateway. It's acting as a bridge between our private subnets through our public subnet to our internet gateway. So what we need to do in order to make that a gateway is we need to disable our source and destination checks. So in order to do that, let's click on our NAT instance. You can see that it is now running. I need to go over to actions and go over to networking, and in here I need to change my source and destination check, and I'm going to go ahead and disable it. So that has now disabled it. So now, in order to get my database server to talk to my NAT instance, what I need to do is create a route, and I need to create a route in my default route table so that our EC2 instances can talk to our NAT instance. So let's go over to our VPC, which is under Network and Content Delivery. Then we're going to go over to our route tables in here. We're going to go to our main route table for our custom VPC and go in here. And in here, we're going to go in and add our routes, go and edit your route and go and add a route. And we're basically going to say if we want to go out to the internet, so we want o.o.o.o/o, then what are we going to do? Well, we're going to use an instance. And what instance are we going to use? We're going to use our NAT instance. And so we're going to go ahead and hit save root. Okay, so now that I've done that, I've got a route out, hopefully to the internet in my main route table. So in my main route table, we're saying go over to this Elastic Network interface. So let's go back over to services, go back over to EC2, and I want you to grab the public IP address of your web server. And then what you want to do is go ahead and SSH in using this public IP address. So I'm just going to SSH EC2-user and then at my public IP address and then using my key. And that has now SSH'd in. I'm going to elevate my privileges to root. I'm going to clear the screen. Then I'm going to do, if I type in ls, I still have my private key from the last lecture. Then I'm going to do exactly the same command, SSH EC2-user and then at. And it was 10.0.2. I think it was 235 from memory. And then I'm going to use my private key, which is my pvkey.pem. Don't forget your private IP address will be completely different to mine, so do make sure you're using the right one. And I've now SSH'd in. Again, I'm going to elevate my privileges to root. I'm going to go ahead and clear the screen. And now I'm going to go and run a yum update. And if this works, it means we've got a route out to the internet. And there you go. It is now using my NAT instance to go in and create, basically go in and do an update to the operating system for my EC2 instance. And that has now finished updating. Now, the problem with this architecture is that this is a single virtual machine. It's a small virtual machine, so it could get easily overwhelmed. Imagine if we had thousands of EC2 instances in private subnets all trying to download things at once, and it's all connecting through this. This NAT instance is a massive bottleneck, and it's just got a single point of failure. If I go in and terminate this instance, it's now going ahead and terminating, and that has now terminated. If I go back over to my terminal window and if I run a, let's say yum install httpd -yes, so I'm trying to install Apache, you're going to see that it's going to time out because it no longer has a route to that NAT instance. What we might want to do is just go back over to our root table and remove that route because that NAT instance is now dead. So we go over to our root tables and we click on our main root table and click on routes. And you can see here the status has turned into a black hole. And the reason it's a black hole is because this instance no longer exists. So let's go ahead and remove this root and go ahead and hit save. And we're now going to go ahead and close that. So how can we fix this? How can we make it so that we have a much more highly available and scalable solution? Well, let's go over to NAT gateways. We're going to go ahead and create a NAT gateway. So first of all, ask us what subnet do we want this to be in? And of course, we're going to want this to be in our subnet that is public. Now, annoyingly, the UI just gives us the subnet ID. So what I might want to do is just go back and confirm which subnet is my public one. So it's 10.0.1.0, so it's ending in AEE. So I'm going to go back over to my NAT gateway. I'm going to go ahead and create it. And in here, I'm going to choose AEE. So that's my public subnet in there. And then I'm going to create a new Elastic IP address, and that will then attach it to my NAT gateway. And then I'm going to go ahead and hit create NAT gateway. And that has now been created. We are going to need to edit our root tables to point to this NAT gateway. So let's click on edit root table in here. And we're going to go ahead and edit our main root table. We're going to give it a route out to our internet. So we're going to add our route. We're going to go o.o.o.o/o. And in here, we're going to change the target, and we're going to click NAT gateway, and then we can see it in there. I'm going to go ahead and hit save route and hit close. Now, NAT gateways can take some time to be set up. You can click in here and you can see that the status is pending. I'm going to pause the video while I wait for this NAT gateway to come back up. And then I'm going to go back over to my private EC2 instance, and then I'm going to go in and try and install MySQL. Okay, so that NAT gateway is now available. I'm going to go over to my private EC2 instance. Okay, so I'm back in here. I'm just going to clear the screen, and I'm going to go in and go yum, and then I'm going to type install, and then MySQL, and then -yes. And there we go. It's now using my NAT gateway to install MySQL server. So onto my exam tips. NAT instances are completely out of date, but they are still in the exam. I literally just did the exam 2 weeks ago and I had a question on NAT instances. Not many people use them anymore, and the reason that is there's a few issues, and we'll go through those in a second. So just remember with NAT instances, when you create a NAT instance, you need to disable your source and destination check on the instance. Your NAT instance must be in a public subnet, and there must be a route out of the private subnet to that NAT instance in order for this to work. And the amount of traffic that the NAT instance can support depends on the instance size. And if you're bottlenecking, all you need to do is go in and increase the instance size of your NAT instance. And you can create high availability using auto-scaling groups and multiple subnets in different availability zones and a script to automate failover. So it is definitely possible, but it is a pain in the butt. And NAT instances are always behind a security group. So we put our NAT instance into our web DMZ security group. NAT gateways. NAT gateways are redundant inside the availability zone. They're not a single EC2 instance. They can survive failure of the EC2 instances that power NAT gateways. So they are redundant inside the availability zone. That being said, though, you can only have one NAT instance one NAT gateway inside one AZ. NAT gateways cannot span AZs, and we'll come to that in a second. NAT gateways are definitely preferred by the enterprise. They start with a throughput of 5 gigabits per second, and they scale currently to 45 gigabits per second. That will increase throughout the year. Don't worry, you'll never be quizzed on like configuration maximums inside AWS. This isn't a VMware exam. Just remember though that it does scale automatically. You don't need to go in and patch the operating system for your NAT gateways. You do have to do that for your NAT instances. Your NAT gateways are not associated with any security groups. We didn't have to go in and add it to my web DMZ security group. Your NAT gateway is going to automatically be assigned a public IP address, and you just need to go in and update your route tables for your NAT gateways, and there's no need to disable your source and destination checks for your NAT gateway. And then finally with NAT gateways, just remember if you have resources in multiple availability zones and they share one NAT gateway, in the event that the NAT gateway's availability zone is down, then your resources in the availability zones, in the other availability zones, are going to lose internet access. So if you only have one NAT gateway in one availability zone and it is a single point of failure, you should always have a look at having multiple NAT gateways and create an availability zone independent architecture. And so you want to create a NAT gateway in each availability zone and configure your routing to ensure that resources use the NAT gateway in the same availability zone that they're in. And we'll talk a bit about that more in the high availability section of the course, which is the next section of the course. So always try and use NAT gateways over NAT instances, but do be aware that NAT instances are still going to be tested in your exam. So that is it for this lecture, guys. If you have any questions, please let me know. If not, feel free to move on to the next lecture where we're going to look at network access control lists.